Welcome everyone to the topic Introduction to Concrete Technology. So basically, what is a concrete, right? So whatever we see in our daily life, from that we can understand concrete is mainly having the components, the fine aggregate or sand as we know, and coarse aggregate, the fragments of rock as we see, and the other important component is cement and water. So whenever we add all these constituents together, the resulting product is concrete. Now, what is concrete technology, right? So whatever uh, areas which are related to concrete, like the study of its properties, its applications, okay, this all comes under the term concrete technology. Also, what we will be studying is, as we can see, concrete is a material which is made of so many components. So their influence, the type of the raw materials being used, and also their sources and very much of their quality will influence the overall resulting concrete. So their influence and their characteristics, their studies is also very much into part of the concrete technology. So with that understanding, see, the concrete as we see today has gone a lot of changes right from the time it has begun being used in history. So, if we see the timeline, as early as 6500 BC, the first traces of concrete can be seen in the regions of Syria and Jordan. From there, the next evidence was in 3000 BC, where very much we are familiar with pyramids, and in the construction of pyramids also some traces of gypsum mortar or mortars of lime can be found. Also, what we mostly know is like in around 600 BC, and more precisely around 200 BC, when it was more frequently used in Roman Empire, they used a kind of volcanic ash, lime, and seawater to form the mix. So it is very far from the concrete what we see and understand today. So the next breakthrough came in like 1793, where John Smeaton used limestone, containing clay, and that was fired until it turned into clinker and then ground into powder. Now here, this process, what John Smeaton found out was something very important, because this is what the precursor of the cement we see and understand today, right? And later on, in 1824, Joseph Aspirin invented Portland cement by burning finely ground chalk and clay until the carbon dioxide was removed. Now, this is where our modern cement has come from. Like that is why our cement is known as like ordinary Portland cement. So from here you can see that as we talk about concrete, and cement is like a very important and irreseparable part of this, right? So the before moving to the sub components, let's see what are the advantages of concrete, right? Why we are using it. So the first of all, if you see, it's like durability. Of course, we see in our buildings like concrete is extremely durable and long lasting. That is one of the reasons, like for every purpose we are trying to use concrete, right? Then it is like cost effective. Now, cost effective, if you see, if something is durable and long lasting, we have less need of maintenance, hence it will be cost effective and low maintenance as well. So it will be good in long run, right? Also, we know that it is water resistant, so temperature resistant, and of course easy to mold. So nowadays we see like any form of building, if we just have the casting components in the desired shape, we can just pour in concrete and we can get the desired shape structure, right? So moving to the steps of concrete production. So when we are thinking as the concrete to be the end product, right? So what are the steps we have to go through? First is the material testing. As I have told you, all the sub-components like sand and stone chip, this is fine and coarse aggregate and cement and water. This all has to be of good quality so that and good quality, and also I will say desired quality, so that the end product which we are aiming for is also good. So material testing is a very important component, right? And once we are done with the material testing part, we get the properties like specific gravity, water absorption, all the important properties which are required to do a proper mix design, which we will see in the later part of this subject. So next step comes is the mix design. Okay, so once we have the mix design done, we know how much amount of what is being or will be needed, for doing the concreting work. So once we have the amount, we just need to mix, right? And then the step is called casting, where we have the ready concrete poured into your shutterings. And once your casting is done, what we do, we remove the shutters in the specified time as mentioned in our respected IS code, and then we do curing. Okay, so these are the very very general simplified steps of concrete leading to our end product. uh, Not concrete person, I will say construction, right? So the next, so concrete and cement are like very inseparable. So the first and foremost topic we need to cover is the cement. Okay. So what is cement? So if we see our history of concrete, right? Traces of concrete to the Portland cement. So the cement as we know now, what are the manufacturing steps of it, right? First is mining of the raw materials. What kind of materials? Calcareous materials and argillaceous materials. Now these materials are grinded into fine powder, which is known as the raw meal. Then it is blended in correct proportions. Okay, so whatever is needed, that is blended, and then it is burned. Okay, and finally uh, what we get is the burnt product, what we can see here, right? This portion, these are the clinkers. Now this will be grinded with some 3 to 5% of gypsum, okay, to stop the flash setting. This is a very important step. Now this is a very general outline of how it is done, but in the manufacturing aspect there are two three ways, okay, like wet and dry. So the where we have like three processes: wet, dry and semi dry. Now depending about like how we are doing the manufacturing process, like grinding and blending of the material, if in that part we use water, okay, so then it becomes a wet process. So what is happening here, like grinding of raw material, if we are using water, it resulting into slurry. Then again we dry it in a clean and do calcination, right? Whereas in the dry process, what is happening, we are adding the raw material into, we are breaking into very fine powder, and we are directly giving it, feeding it into the clean for clear calcining, right? And therefore the moisture is about only 1 to 2%, whereas in the slurries water content is about 32 to 36%. Okay, in the wet, if we see, compare wet and dry processes, wet is comparatively simpler operation. It will have a low dust and easy conveying because it's in a slurry form, right? Whereas in the dry case, it will be like a lot of dust is expected from this process, but it is energy saving, high production efficiency, and it has a stable output, right? Now if we see, the wet process is not suitable to produce where the clinker has a very high rate of silica and high rate of aluminum oxide. Okay, so These are the few minute things we can note, and also there is a third process called semi-dry. Now, this semi-dry process is somewhere we use water, more certain amount of water, which is of course more than the dry. Okay, so it is somewhere in between. Okay, so the next part is our cement. Okay, this is a very important slide. You see where the chemical composition after all this manufacturing process, the end product, the cement, is actually having the main oxides as lime, silica, alumina, iron oxide, magnesia, sulfur trioxide, so and potash, right? And the various percentages are also given here. Lime and silica, you can see, is the major component of the cement. The same can be seen from here. Okay, this figure, this depicts, this is the magnified image of a cement particle, and here you see all the products. Okay, so next is the slide which is showing you the chemical requirements for ordinary Portland cement as per our IS 269 2015. So, depending on the various grade, you can see OPC. OPC is ordinary Portland cement, OPC 33, OPC 43, right? For different grades, the ratio of the different elements are mentioned in our code, and we this accordingly, like whenever we are purchasing cement or all the cement products, we should be very sure if the bag has this code written on it, right? Or it is specifying that it follows the conforms to this code, so we can say depending on the grade, these are the percentages of the chemical composition present in the cement, right? So moving to the next thing is, whenever, now you see, whenever this cement clinkering, these things are forming, the four major compounds, okay, the four major compounds which we generally found is the tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. Now these are the chemical formula, and this is the abbreviated formulas which are formed, and these four compounds are the major compounds and known as Box compound. Okay, and here C stands for CaO, S stands for SiO2, A stands for Al2O3, F stands for Fe2O3, and H is H2. So this is very important. So according to the books calculation, we can actually find the percentages of major compounds, and these are the few formulas stated by him. Okay, depending on the composition. Now, what are the major important points we need to remember? That is, minor oxides like K2O and Na2O, if we see, these are very less amount, right? They react with active silica in aggregate, and these are the, whenever we add water to cement, right? Whenever we add water to cement, these are the oxides which actually react with the active silica present in the chemical composition you've seen. It reacts with the silica in the aggregate, and it produces alkali silica gel. Okay, and now this gel is like a very expansive, so always swelling type of. So whenever something swells, so we can understand if this kind of gel is present in our concrete, and by somehow some moisture or temperatures, like it reaches, it's favorable there, what will happen, it will become a unlimited swelling type of thing. And whenever, if it is swelling, what will happen, there will be an expansion, and this expansion will lead to further voids and crack, and is in one of the reasons where you can observe crackings in concrete. Okay, then the major other point is that tricalcium silicate and dicalcium silicate. These two components are responsible for strength. Now together this part, they constitute about 70 to 80% of the cement. Average C3S content is about 45%, right? And C2S is about 25%. Now SO3, this component actually, its presence in cement is due to the adding of the gypsum. So it is coming from there. Now MgO is around 4 to 1% and 5% is the maximum range. Now this is also very important because it also leads to abnormalities in it, leads to the expansion from the hydration of this oxide. Okay, and lime, that is CaO, beyond certain value, if it is present in your cement, it leads to unsoundness in cement. So these are few things we should be cautious about. Now with that, there is a term like we had seen in the last slide. There is a reaction, right? So cement, if whenever we are adding water to it, a certain type of chemical reaction is happening, which is actually leading to this binding property. Now whenever we add water, what we are getting, the reaction is essentially an exothermic reaction, so it is liberating a lot of heat. Now we can see the chemical reaction in two ways. Okay, that is one solution mechanism, one solid mechanism. Now what is a solution mechanism? Solution mechanism is, we can imagine it like, we in water and cement, whenever it is reacting, it is forming a saturated solution, and once a solution gets saturated, the compounds are getting precipitated. Okay, this is one way of understanding, or one way which it is said to be happening. Other state is a solid state. Now what is solid state? Solid state mechanism we can understand in a way like, the cement is dry cement is a solid particle, and when the water is attacking, it is attacking the cement from surface to inside. Okay, and on the way it is going on reacting. Now in reality, it has been reported that actual chemical reaction is a kind of combination of these both mechanisms. So solution mechanism is occurring essentially in the early stages, early stages when cement is being added to water. So there is a lot of water and to react with. They are forming saturated precipitations. And once in the later stage, when there is a sufficient precipitation is there, the solid state kind of mechanism is taking place, right? So this is how we understand the hydration of cement. So if we see, what we understand is, if this hydration of cement is liberating a lot of heat, because it is an exothermic reaction, this heat is known as the heat of hydration. Now if we see the graph in my right side, okay, rate of liberation, calorie per gram per hour and times per hour. Here the graph shows peak, then descending, again peak, and again a descent. So how do we understand this? Reaction of the solution, whenever we are adding water to the cement, first reaction is my aluminates and sulfates, they are reacting and rapidly reacting. Okay, and there is a lot of heat, and this is the first peak we are seeing here. And then the gypsum we had added, you remember that the gypsum acts and it kind of suppresses the heat, and it goes down, because gypsum's main purpose of adding was to stop the flash setting. So it just went down, so there is a decrease in peak. Now when the hydration product is getting precipitated of the cemented particle, that is also like acting as a barrier, okay, for reacting. So there is a temporary delay, that the reaction, like it was so fast, this reaction, or we can understand that ascending on the peak is comparatively slower, because the reaction has formed precipitations which is creating a barrier into further reaction of the unreacted materials. Now, once it reaches the peak, what is happening here? The formation of erringite, like which with the particles we can see under microscope is this figure. Hydrous calcium aluminium sulfate mineral. Okay, the formula is this, and reaction of C3S. These both are taking place at this point. Okay, this two, and then again when these reactions have taken place, again there is a decrease in the peak. Okay, now we need to note that in this figure where fraction of hydrated of these components are shown with days, we see different elements present in the composition have a different reaction rate, right? And that is being is shown here. So all of them in a combined affect the all this heat of hydration that is being liberated, right? So, what are the things we should note? That is importantly, normal cement generally produces around 89 to 90 calorie per gram in 7 days and 90 to 100 calorie per gram in 28 days. Okay, and reaction is faster in early stages as we have seen, right? And it continues indefinitely at a decreasing rate. Okay, this is very important. It's not that we are curing for 28 days and the reaction stops. There is a continuous, reaction going on, and it decreases with the time. With decreasing rate is there with time. Okay, now complete hydration of cement is not possible. Okay, if we see whatever we do, the complete hydration of cement is not possible unless and until your cement particle is very finely grounded and re-grounded with, that we make sure that every particle is exposed to water, okay, at intervals. Then only, like, otherwise in what we do, complete hydration of cement is not possible. Then therefore, if complete hydration is not possible, then what is the resulting? There is an core of C3S surrounded by a layer of hydrated silicate. Okay, what is happening, like, since complete hydration is not possible, so C3S is there and it is unattacked. So why water is not being able to attack it? Because there is a layer of hydrated silicate, okay, and which is impervious to attack, so it is furthering slowing the attack. So this is also one of the thing which we can relate why the graph is going down and there is a indefinite decreasing rate, right? Also complete and the last point is complete hydration of cement is possible only when the cement particle is smaller than 50 mole, right? So these are the few points we can note related to this, and this is the references I have used for this slide. Thank you for watching.